class on Monday, we reviewed the definition of a function, and we talked about different examples of functions and non-functions and talked about why a specific relation was a function or why the relation was not a function. So I'm going to do that with you now so you can catch up on what you missed on Monday. Number one, when you look at this graph, you can see that this is a function. I'm just going to put yes if it is a function, no if it's not. This is a function because it passes the vertical line test. So when I say the vertical line test, I mean that I'm drawing a line that is parallel to the y-axis. So it's perfectly parallel to the y-axis. It's a vertical line. And any vertical line that I draw, if the relation is what is drawn in red, if the relation is a function, then any vertical line will only pass through the relation one time. If at any point the vertical line, any vertical line, passes through the relation more than once, it is not a function. There is no place on this relation where I can draw a vertical line that goes through more than one point. So we know that it's a function. Number two, again, we are going to use the vertical line test for this graph. And you can see that when you draw the lines parallel to the y-axis, I know I didn't do the best job drawing parallel lines, but when you draw those, each of the lines only goes through the relation one time. Basically, that means that for every x value, there's only one y value. So yes, number two is also a function. Number three as well is a function. It passes the vertical line test. Any vertical line that I draw will only pass through the relation one time. So that means that for every x value, for example, for an x value of 2, there's only one y value, and there's the y value right there. If there were two y values, like there was another y value up here, then it would no longer be a function. So for every x value, there's exactly one y value. Let's look at number 4. In number 4, we get to our first relation that is not a function. When you draw a vertical line through this relation, the line passes through the relation twice. So that means for the x value of 1, there are two different y values. There's a y value of approximately 3 and a y value of approximately negative 1, 2, 3, 4. So since we have, for the same x value, we have two different outputs. Number 4, no, it's not a function. It's not a function. Number 5, again, this is not a function because a vertical line passes through 2 points. It is only allowed to pass through 1 point. Now, my question for you is, what about this line right here? This vertical line only touches the function, or only touches, sorry, not the function, only touches the relation one time. So does that mean that since it only touches it one time right here, that's a function? And the thing is, what I've already said is that it's not a function, and that is true. The reason is this. If there is any vertical line that can pass through more than one point, that is not a function. So it's not enough just to have one line that passes through one point. Every single vertical line that you could draw must pass through it only one time. So no, number 5 is not a function. For the x value of, for example, negative 1, we have a y value here, and we have a y value down here. Number 6 is a function. It passes the vertical line test. Any vertical line that you draw will only pass through the relation one time, so that means that for every x value, there's only one y value. Now we're going to look at a set of tables and a set of groupings of numbers, and I want you to recall your vocabulary. So when we look at number 1, on the left side, we have the domain, and the domain is made up of 1, 2, and 3. 1, if you look at that separately, is one number that is a part of the domain. The range includes 4, 5, 6, and 7. We also call the x values the input and the y values the output. For it to be a function, every input should have only one output. And when you look at this problem, number 2, the x value number 2 has an output of 6 and an output of 7. So that means that this is not a function. No, A is not a function. In B, each x value has a y value of 5. An input of -1 has an output of y of 5. An input of 0 has an output of 5. An input of 2 has an output of 5. An input of 3 has an output of 5. And this is a function because every input only has one output. For -1, there's only one output, 5. There's no other output for -1. So this is a function. And the rule for this would be y equals 5, which would form a horizontal line. If you think about putting those vertical lines through it, you can see that it will pass the vertical line test. In C, when you look at this problem, one x value has multiple outputs, and that's a problem. This is not a function. And it's not a function because 8 has an output of -1, 8 has an output of -2, and 8 has an output of -3, so it's not a function. In D, we have our x value of 0, which has an output of 8, x value of 10, which has an output of -32, and last in our domain, we have an x value of 20 with an output of 3. Each x value has only one y value attached to it, so yes, this is a function. And our last set of examples, in E, -7 has an output of 3, and 9 has an output of 3. You are allowed to have a copy of y, that is okay. From the 3, we have 2 lines coming from it, and that's perfectly fine. The problem is when you have 2 lines coming from the x value. So if -7 had 2 different outputs, that would be a problem. But this is not a problem to have 2 different x values that have the same y value. You're allowed to have a copy of y. So it is a function. In F, yes, this is also a function because every x value has only one y value output. In letter G, no, this is not a function because x has an output, an x value of 1 has an output of 7, and an x value of 1 also has an output of 9. Letter H, this is a function. Every x value only has one y value. You'll see that there's a copy of the y's, but still, -2 has an output of 5, and -2 does not have any other output. 15 has an output of 5, and 15 has no other output. So there's no issue here. This is a function. We are also going to identify the domain and the range for G and H. For G, the domain is 0, 1, and 2. You'll notice that even though the domain has 2 1s, I don't list it twice. I only list it once. For the range, we have 3, 5, 7, and 9. 3, 5, 7, and 9. For H, let's identify the domain. For the domain, we have -3, -2, 15, and 17. For the range, we have 5, 8, and -8. And you'll notice that even though there were 2 listings of 5, I only listed it once when I put it down for the range. So the range is -8, 5, and 8. Or you could say the range goes from -8 to 8, and you could say the domain goes from -3 to 17. And that's all on functions for today.